Hey guys, my name is Alian Jawani, and today I'm going to be going over my topic, which is over exoplanets. Exoplanets is a really cool topic that I got to work on for this project, and so I'm really interested and looking forward to sharing this with you guys. I'm going to be going over this presentation like I have an audience, so I'm sorry if this is going to be sounding a bit weird or I feel like I'm probably going to be talking to myself, which is fine. But overall, this is going to be, I really enjoyed this project, so let's go on with this presentation. A few things I'm going to be covering are what exactly are exoplanets, the different types of exoplanets, why why they're important, how astronomers measure them, and then just everything, any type of fact or information regarding exoplanets. So let's get on with the presentation. So you may be wondering, what exactly are exoplanets? An exoplanet is basically any planet that orbits around a star other than the sun and is located outside the solar system. Now, so over here I also have an image of just a brief image of exoplanets, so I hope you find that really cool. Cool fact about exoplanets are there's actually more than 1,000 known exoplanets today, and there's more being discovered constantly, so that's one cool thing about it. So let's go on with the next slide. So the next slide, I basically talk about some general information and just some regular facts about exoplanets itself. So one of the first exoplanets was actually discovered in the 1990s, where they found it to be orbiting a neutron star. And then another cool thing about are that they come in a wide variety of sizes, and that has to do with the different types of exoplanet types. So that has to do with gas giants, Neptune-like, super Earth, and terrestrial types of planets. And so in this presentation, it's good to know what exactly a habitable zone is. And so a habitable zone is an area around a star that is not too hot or not too cold to liquid water, so it can liquid water to exist on the surface of surrounding planets. It kind of gives us a better look on whether a planet could be habitable and for it to have life. And so a cool thing is the Kepler 186f was one of the first rocky planets to be found within the habitable zone. So that's just some cool facts, some cool information. Let's go on with the next slide. So there are again there are different types of exoplanet types. So let's start off with gas giants. A gas giant is a giant planet mainly composed of gas, and temperatures are extremely high. It's usually similar to Jupiter or Saturn. Super Earth is more massive than Earth and is lighter than Neptune, and they have nothing like them in our current solar system. Neptune-like has to do with has similarities to Uranus or Neptune, and have hydrogen and helium dominated outer atmospheres and a rocky core. And then overall, a terrestrial is just rocky and is also in the same size range as the Earth. So how exactly do we find exoplanets? So exoplanets again are like a dozen light years away, which makes it very hard to find in the solar system. One of the closest exoplanets is, I think, 40 light years away. But I might be wrong actually, so I don't want to wrongly state that. But astronomers use plenty of methods to discover exoplanets. So they use indirect methods, which are pretty popular, such as radial velocity, transit, direct imaging, and gravitational microlensing. The most common methods that are the most useful are mainly transit and radial velocity, and a direct method is, of course, telescopes. So radial velocity is also known as like a Doppler spectroscopy, which is used by observing the Doppler shifts in the spectrum of the planet and the parent star. Over here, I have like a cool image, just kind of going over the process of the radial velocity. So it's really cool to see that so it basically uses the Doppler effect, which Doppler shift, which is basically how light from the star is shifted towards the red or blue end of the spectrum. So it's really cool just to see that image and just see exactly how radial velocity works. It's definitely one of the most successful ways of finding exoplanets. Another one of the most, this is also another successful way that astronomers and scientists have found exoplanets is by transit. This method determines the planet's radius by waiting until the planet crosses in front of the parent star, and then the visual brightness of the star drops a small amount. And so the amount of the star dims depending on the relative size of the star and planet. Again, this goes over the fact that exoplanets, they come in all different types of sizes, so that's just really cool. And so over here down in this diagram, it also just shows like the process of transit and how exactly it goes. So it's super cool once again. And then there's direct imaging, which is basically taking a picture of the star and blocking out the starlight to see if there is a planet. It's one of the oldest methods of detecting exoplanets, but it's still used today. Not as much successes as compared to transit and radio velocity, but still pretty helpful. And then there's gravitational microlensing, which is light from a distant star being bent and focused by gravity as a planet passes between the star and Earth. I also have an image down below that's demonstrating that. I'm sorry if you hear fireworks. Fireworks are going on. There was Diwali a few yesterday, and so I'm sorry if that's coming through. But over here, yeah, basically the gravitational microlensing is light from a distant star being bent. So it's really cool. This image has a great way of showing it, what exactly it is. And then lastly is telescopes. So one of NASA's discovery was with the Spitzer Space Telescope. They were able to capture the first known system, 7 Earth-sized planets around a single star. And so this was really cool. It's just knowing that there's 7 other planets, 3 of them actually alike, that like the Earth, that have possibility of having liquid in them. So the discovery actually set a new record for the greatest number of habitable zone planets found around a single star outside the solar system. So that's actually super cool. And over here, I just got a picture of the Spitzer Space Telescope. It's actually a really cool telescope. Seeing this in the image, I really like it. And so this is the TRAPPIST-1 system. This is basically what they had captured. So there are actually 3 terrestrial planets that are much like the Earth, as I stated in the previous slide, located in the TRAPPIST habitable zone. And so this is actually 40 light years away. And so that's quite far. That's really far. But overall, it's really cool. Um, And it's just cool seeing that maybe like one of these planets could be able to contain life. So you may be wondering like why exactly is this important? And so one way of wondering why this, and a lot of people ask like why is this important? Well, what was the point of learning about exoplanets? And the main thing has to do with that they not only help us identify objects in the sky, and but they can possibly tell us if there is a possibility of life, especially because because other galaxies are plenty of light years away. So as we continue to find exoplanetary systems, we're still faced with the issue of how we're faced with the issue of how that they're pretty far away. Again, this is probably the relatively closest system, which is still 40 light years away from us, but it helps us know, which planets could have water and could be assigned to life, which is an ongoing curiosity that many do have. I have that as well. And over here, I got a picture of Elon Musk because he's a cool guy and he actually wants to colonize Mars. And so I just thought it would be cool to add it on here, and why not? So over here, I also have some pictures of potentially habitable exoplanets. There's some cool names. There's the Kepler 62e. There's, I would say, Gliese 581g. So there's a couple, and they come in variety of sizes, as I said before. And look on the top right, as you can see, Earth. So you're able to compare these to Earth and see how they're similar. And so this is just another way, another few pictures. Oh, okay, so this is also the TRAPPIST-1 system. So I just thought that was really cool to add on here just to see how that compares to our solar system. And so just want to add that. And then these are my sources. So also another thing I just wanted to add is that no one is like sure what the discovery of like a new potential habitable planet will mean for us. Maybe it will be an inspiration. Maybe it'll be like an inspiration for future unmanned or even like manned missions to explore new worlds, or even to colonize in the future, like Elon Musk wants to do with Mars. So maybe they can even hold to answer the question: Are we alone, and is there life out there? So overall, that's my presentation about exoplanets, and I hope you guys enjoyed. Thank you so much.